All right, welcome back. We are going to talk about sleep and dreams in this segment. I think this is probably going to get cut into two parts because you guys will die of old age before I get through this full conversation about sleep and dreams. Thought this cartoon was pretty funny. Let me get this straight. It's been 2 consecutive hours since you slept. um, that would be insomnia for a cat, right? They sleep a lot. We all have our own sort of circadian rhythms that determine how much we sleep and how much we're awake. But on average, we share a lot of things in common. So let's talk a little bit about those shared daily rhythms and sleep patterns. So through research on participants who are willing to go into dark caves and live there for like 5 months at a stretch, researchers have discovered that the natural rhythm of the adult human is about a day. And it's considered about a day because people who go into these caves where there is no natural light or any cues about what time of day it is, they tend to slip into a 25-hour day. Now, of course, that's problematic because we live on a 24-hour day, right? So for us on the land, on the surface, we probably take that hour out of sleep. Like we probably are all not getting as much sleep as we should. We definitely are lacking 1 hour in the day that our body would like to see. It's kind of interesting that we have a different circadian rhythm than the way that the world actually works. But here's what causes us to feel sleepy. As light's coming in through our eyeballs, it actually goes through the optic nerve up to the suprachiasmatic nucleus. So it's a nucleus that's right above the optic chiasm. And it reacts to the level of light. And it turns out it doesn't matter whether your eyes are open or closed. The suprachiasmatic nucleus can still collect light. You know how you can see light through your eyelids. So even if you're asleep, that suprachiasmatic nucleus is collecting that information. It sends the information back to the pineal gland, and if it's light out, the pineal gland determines that it's time to stop producing melatonin. And so during the daytime, we have less melatonin flowing through our blood than when it's dark. When it's dark, the pineal gland secretes more melatonin. Melatonin makes us sleepy. About 2 hours before a natural awakening, the pineal gland will shut down that production and get you ready for the daytime again. So it's a very cyclical thing, normally in response to light. We will secrete melatonin when it's time, about 2 hours before we're supposed to go to sleep, and then we stop secreting it about 2 hours before we would naturally wake up. Now, the problem is we have alarm clocks, and we have the artificial light, and we have all these things that can really interfere with that natural production. One of the things that we know about how the day works is that we are not the same all day long as far as biological functioning. Our body temperature fluctuates across the day. While you're sleeping, your body temperature drops, and that's what helps to keep you asleep. And that's why we need blankets while we sleep, even when it's reasonably warm out. During the middle of the day, a lot of times people will have another dip in body temperature, and it makes them drowsy. We have fluctuating arousal and energy, right? Because as our body temperature is fluctuating, we also fluctuate on how much we want to take a nap, or whether it's time to go to bed, or whether we're feeling, low energy at the moment. And then how sharp we are mentally. There are different times of the day when you may feel really acutely sharp, and you could write, and you could be creative and other kinds of things. Other times you're like, I can't focus at all, right? Those are probably responding to your natural daily rhythms. Some of us are what they call larks. I was kind of concerned none of us know what a lark looks like, so I got a rooster instead to stand in as a lark. Because roosters like mornings, don't they? Apparently larks like the morning. I don't know. I don't know what a lark looks like, frankly. But people who are labeled as larks are people who really are the most alert in the morning. They wake up, they're ready to go, they do their best work, they do their best thinking, stuff like that. It turns out that children tend to be more like larks. Full-grown adults tend to be more like larks. The people in the middle tend to be more likely to be owls. they're most alert in the evening, maybe late afternoon possibly. Being an owl is most characteristic of adolescents and young adults. So that means for all of us, we probably were our most lark-like when we were children. When we went through our adolescent and young adult period, which some of you are probably still in, it became harder to get up in the morning. You want to stay up later at night. You feel like you're just getting your energy, stuff like that. And then once you fully mature into adulthood, you may find yourself returning back to a more like lark-like pattern. But having said that, even among children, some are more get up and go in the morning, and others are more stay up late. So people vary across the lifespan. They think that this might be a little bit simplistic to say that you're a lark or an owl because they've identified, for example, some people who are not very good in the morning and not very good in the evening. They're really very good in the middle of the afternoon, and that's their period. And so they're trying to figure out what bird functions best mid-afternoon. But so it's not perfect, but you might see a pattern that sort of describes you as you're looking at these two different types of, circadian rhythms. One of the things I'm thinking about how to collect data on is I just completely anecdotally talking to other people. It seems like people who are in long-term relationships with each other, like years and years and years, and live together and like that, it seems like one is a lark and one is an owl. I can't think of anybody I've met yet where both are owls or both are larks. It makes me wonder if that's part of finding a partner is finding somebody who has a different, tendency than you do. And I could think of the advantages, not to sound like an evolutionary psychologist, but I could think of the advantages of having different styles than your partner. Like just a really easy one, child rearing is a good one, because then one of us takes the early morning shift and one of us takes the late night shift. Or back when we were farmers, agricultural, it would be a good idea to have some of the people in the house, willing to get up in the morning and milk cows, and other people who are more willing to go out at night and make sure the animals are all settled in the barn and stuff like that. We can kind of imagine that it might be an advantage, and I don't know if it could just be completely anecdotal and I'm just making stuff up. I need to do some quantifiable data to find out if it's true that couples tend to pair up with their opposite as far as circadian rhythm. All right. I have a little early birds versus night owls video that I like to show also that kind of explains the difference, and they do a good job with these. I always like these whiteboards. I don't know if these whiteboards are out of style now, but I really like them. Can't draw them, but I enjoy them. So I'll link that up in our classroom. I'll try to make sure that all of these are linked in the classroom. If they aren't, you can always, Google them yourself, because I just pull everything off of YouTube. I don't really have access to much different than you do. So I use a lot of YouTube. So some non-REM sleep stages. Okay, they found out in the 1940s that when we fall asleep, we do not just lose consciousness and lay there all night, that literally our brains do different things throughout the night. So the Air Force got a bunch of recruits to wear an EEG setup where they had electrodes on their skull and tracked brainwave patterns across the night. And they discovered that there are several sleep stages that we go through several times a night. So let's check these guys out. So the non-REM sleep stages. Our textbook lumps a bunch of them together, by the way. So, if you really find sleep interesting, there's a lot more detail that we could be going into than we are. So non-REM stage 1. So this person laying here is technically asleep, but they are really lightly asleep. You can tell that by how small those little waves are. The amplitude is very small, and they're pretty close together. That's pretty tight. So it's still fairly active, but really small. So not a lot of activity, not a lot of intense brain waves, but a lot of brain waves. During this stage, you're experiencing what we call the hypnagogic state, which is where you're really prone to hallucinations. You may feel like you're floating. You might feel like you're falling. You might feel like you're swirling. I've had students report in their hypnagogic state observations that they felt like they were being swarmed by spiders, or other kinds of scary things. So these are hallucinations that you might have. These are not dreams because they are just sort of visual and you kind of feel them. Hallucinations are sensory experiences that aren't really happening, but your senses think they are. So you feel like you're falling, right? It's not just you're dreaming that you're falling. You literally feel like you're falling. Non-REM stage 2 is a little deeper sleep, and one of the things you can tell is that occasionally there's some pretty big spikes going on in this EEG pattern. And you can also see these little bursts of activity, these little sleep spindles that happen during non-REM stage 2. So you can tell that this person's in 2, not 1, because of those, those occasional big spikes and those bursts of activity. The thing that's really unique about stage 2 is that it is the stage when you're the most likely to sleep talk. So if you're a person who sleep talks or you have a sleeping partner who sleep talks, they're probably in stage 2. This is still considered a light stage of sleep. You'd be able to wake the person up pretty easily. What's weird is their own talking doesn't usually wake them up, but sometimes it does. Sometimes as soon as they start to move their mouth and make noise, it'll wake them up because they're lightly asleep enough. But other times they'll sleep through their own voice and they'll wake up if you say something. Sometimes if you say stuff to them, you can kind of guide what they're talking about, which is kind of interesting also. So sleep talking, that's REM stage 2, non-REM stage 2. So both of these share the characteristic of being easy to wake up during these stages. The last non-REM stage actually lumps together 2 stages in reality, but let's just go with it. Non-REM stage 3. What you'll notice here is that we've got some really big waves, and they are more rare, right? You can see there's a lot of space between peaks on this pattern. It looks like the person's asleep, doesn't it? This looks like a sleeping brain, like not that much activity, not very frequent activity, but more when there is activity, it is more intense. This has multiple names. Non-REM stage 3, for one. It's also referred to as slow wave sleep for obvious reasons. When you are sleeping and you have an EEG on, there's a machine that draws the pattern of what the cells, the neurons are doing. And it literally takes on this sort of sleepy, like drawing pattern, whereas it had been going like hopping around. Now it's doing this nice slow wave sleep. So you can imagine why it's called that. This is also referred to as delta wave, because waves that look like this, whether they're generated by your heart or they're generated by your brain or whatever, they're called delta waves. So different names you might see in the textbook or other people talking about it. The key thing to think about with the non-REM stage 3 is that this is a person who's deeply asleep. It's really hard to wake them up. Sometimes you can, pull their arms and try and get them into a sitting position and they still don't wake up. You can call their name, you can clap your hands, and they don't wake up because they're really deeply asleep. This is the stage when people who sleepwalk. This is not a stage when you usually dream. This is a stage that is, if we can wake you up, usually the sleeper will say, no, I don't think I was dreaming. I don't remember anything. So they're usually not sleepwalking to a normal dream if they are having a dream. A sleepwalker during non-REM stage 3 will have their eyes open a lot of the times. I think all the time they have their eyes open. And they move through the environment usually pretty well because they have their eyes open, but they are not awake. You talk to them, they may say something back that doesn't make sense. So it's quite unusual, and we'll talk about that a little bit more when we get to sleep disorders. All right. And a nice GIF of a person sleeping at a sleep lab and experiencing REM sleep. And so rapid eye movement, you see where it got its name, right? Kind of creepy, isn't it? Their eyes roll back, darting back and forth. Notice that there's an electrode under the person's eye. That's because not only do we want to know what's going on in the brain, but you also can pick up evidence that their eyes were moving with the little electrode that's under their eye. So the picture that you're seeing below that, the red lines, that's actually the brainwave pattern. And it looks even, I'm going to take you back one just here to remind you of what non-REM stage 1 looks like compared to REM sleep. This is a very active brain. A lot of waves going on. They're small. When there are eye movements being picked up by those electrodes, you see this pattern that the brain is displaying where there's like that repetitive going on with the brain. So really quintessential, consistent things that we see happening during REM sleep. So what's going on? Well, for one thing, not only do we see that the brain is more active, but the heart is more active. It's pounding, and the breathing is a lot more rapid and shallow. It's like they're actually exercising, or they're very active. So the heart rate's up, the breathing is up. The breathing might sound like ujjayi breathing. You might have learned that term from like yoga, where you're like that kind of breathing. And that's the deep breathing that really oxygenates because my heart rate's up. During REM sleep, almost everybody experiences sleep paralysis. Back when we were talking about the pons, I mentioned that there's a switch in there that flips when the person enters REM sleep that prevents them from being able to move their body. So as motor messages are leaving the motor strip and trying to go down the spinal cord to control your body, it hits that switch and doesn't get passed on to the body. So your body is completely paralyzed. This person, he looks like he's just completely laying there, and the only thing that's moving is his eyes, right? And if we lifted his arm, it would feel like a paralyzed arm. There'd be no muscle tension, anything. Occasionally, you'll see a little bit of twitching in the fingers and the toes. You may have seen this in your dog or your cat. They seem to be running after something. And sometimes they'll even make little yip sounds because they're paralyzed also. But just sometimes a little bit of movement can get through, just a little bit. I've seen videos on YouTube where the dog is twitching, and then actually makes a little bit of movement and then actually stands up. But by the time it stood up, the dog's like awake. Sleep paralysis usually prevents us from getting up and walking around and acting out our dreams. In the 1960s, they damaged that part of the pons that normally has that switch in a cat. And when the cat went into REM sleep, it would get up and act out its dreams, just walk around and do its thing, which confirmed that the pons is where that switch is, and also gave us some insight into what cats dream. Apparently they dream about fighting, chasing, being chased, hunting. They don't seem to have a lot of cuddle up and purr dreams. They seem to have a lot of really active dreams. So most of the time we're paralyzed. They call this stage of sleep paradoxical sleep because the brain is active, as evidenced by this EEG, but the body is completely immobile. It's not moving. You look as unconscious as you can be, but if we look at these internal things like your heart, your respiration, your brainwave patterns, it's like you're awake. So it's like such a paradox. How do you look so dead and internally you're so awake? How does it not wake you up that you're so awake, right? So clearly something's going on during REM sleep that allows for all this activity. One last thing I thought I'd mention, because this is going to be relevant when we get to narcolepsy, but with all this increased heart rate and respiration and stuff like that, it also activates all of your arousal system, including your genitals. So you get genital arousal as part of REM sleep. So the fact that we go through REM stage several times per night means that we experience all of these things several times a night. Speaking of cycles, this is a pattern that you'd expect for young adults. If you're looking at people who are over the age of 40, the sleep pattern probably looks a little bit different because as we get older, we have more periods where we come to wakefulness and return back to sleep. Young adults usually only do that a couple times a night. So what we see in this graph is you start out awake and you lay there for some amount of time. Ideally, you lay there 10 to 15 minutes. If you're laying there longer than that, maybe you're not tired or ready for bed, you're too active, you need to do something else to get ready for bed. And we'll talk about insomnia later. If you're falling asleep the second your head hits the pillow, it's possible that you're sleep deprived and you need more sleep. Because the sort of healthy, they think, target is to spend about 10 to 15 minutes sort of calming down, getting ready to actually then drift off into sleep. So you lay there awake Then you drop into non-REM stage 1 for a brief period of time, like 5 minutes. Then you go into non-REM 2 for 5 or 10 minutes, and then you go into non-REM 3. So we have this protracted period of time where you're experiencing that very deep, restful sleep. Something I forgot to mention during non-REM 3 is that not only is your brain relaxed and it's got that nice sort of breathing pattern, it looks like, you also secrete human growth hormone during non-REM stage 3. So it helps to repair your body. If you've been active, if you're growing, if you're pregnant, something like that, if you've been lifting a lot of weights and need to repair those muscles, you need more non-REM stage 3. And so a lot of times when people are in one of those states that I just described, they'll actually sleep more hours or more minutes at least to make sure that they're getting enough exposure to human growth hormone. Once you've done your first bout of stage 3, then you move back up to stage 2, and then now instead of going back into stage 1, we go into our first REM stage. We have our first dream of the night. It's only going to be about 5 or 10 minutes long, something like that, but that'll be our first dream of the night. And then we go back into a slightly longer stage 2, and then a slightly shorter stage 3, an even longer stage 2, and then a longer REM sleep. Now you've spent 30 minutes paralyzed after that second REM stage. So a lot of times people kind of come a little bit awake, kind of roll over, get their blankets all in place again, and then drop back into sleep. If they fully woke up, they might have spent a second in stage 1, but they might just go right into stage 2. What you'll notice is across the night, you're doing less and less of the stage 3 and more of the REM. So it seems like we front load our body repair sleep, and then as the night goes on, we start doing whatever REM is doing for us as the night goes on. And then we start just alternating between REM and 2, wake up a little bit, REM and 2. If it's a weekend and you don't have to go to work or something, you can go directly from REM to slowly coming into alertness, and you'll probably remember that dream. The only time you usually will remember dreams is if you wake up right after them. So if you ever want to remember a dream, the best thing that you can do is the second you wake up, jot it down on a piece of paper that you keep on your nightstand or whatever, because by the morning you'll have forgotten it. So you have to immediately unload it. All right. So why do we sleep? Well, it feels good, right? Nothing wrong with a little sleep. But we mean in the bigger picture. Why? What's the function? Well, one thing is if you hold still, predators are less likely to find you. A deer walked through my yard yesterday, and it was kind of dusky. Deers love to move through when it's dusky, right? And it stopped. And I looked away for a second because it had stopped. And then I looked back to see it, and I'm like, oh, is he already gone? Nope, he was holding still. He had moved a little bit from where I last saw him, but he was now holding still, and I could not see him. Because us predator eyes, we really cue on motion. And so if we hold still all night, it's a lot less likely that a predator is going to find us. So that's got to be a benefit to us humans. It restores and repairs our body. Right? While you're sleeping in stage 3, you secrete hormones that will help to repair your body. So it's definitely for your body. It physically rests your body. It repairs your body. So, okay, it does that. Releases the human growth hormone that I mentioned. Now we're getting into why you might experience REM sleep, because during REM is when we transfer new information to long-term memory. It turns out that in the absence of REM sleep, you'll forget more things. And we're going to talk about that a little bit more as we go into different states of consciousness. But we'll also talk about it when we get to the chapter on memory, that you need that memory consolidation time. REM seems to be the time that what we call long-term potentiation occurs, which is where the synapses between two neurons actually change in order to represent the new information. That physical change happens during REM sleep, we think. Another thing that sleep does for us is if we've been working on a problem and trying to find a solution to a problem, sometimes we get an aha moment, sudden recognition of the solution when we wake up in the morning. So it's like something is going on in the back of our minds as we sleep that is actually working on problems. So that when we wake up, we may have a solution. So sometimes sort of tabling the problem and going to sleep can help you to solve the problem. Okay, so why do we sleep? Well, what happens if we don't sleep? That's a good question. So the effects of sleep loss or deprivation. Don't know why that slide is cut off here, but okay. We're more likely to lose brain power. You know this is true. You've had times where you're tired and you just can't even concentrate, right? You can't focus. You can't come up with an answer. You're more likely to gain weight. People who get inadequate sleep tend to gain weight over the time that they're getting inadequate sleep. We're more likely to get sick. It actually dampens our immune system to be deprived of sleep. So we need adequate sleep to rejuvenate our immune system. We get cranky, right? You've all seen children who are overtired and they get cranky. Well, we're all like that. We maybe hold it together a little bit better, so we just get snippy. But we're irritable. Things bother us more. We're more likely to cry or lash out, things like that. It makes us feel older. We're like, everything hurts. I'm so tired. How old am I, right? That kind of thing. All sorts of bad things go along with this. And how about we're more likely to have accidents? When we are tired, when we're sleep deprived or just fatigued, we're more likely to have accidents. I'm going to show you this chart that was created by the author of our textbook to illustrate how the spring forward time change, where we all get deprived an hour, impacts accident risks more than the fall time change, where we all get sleep indulged. So we see over here on the left the spring time change. So we have the Monday before the time change in the blue bar. We see the Monday after the time change in the red bar. And you see this spike of accidents going from 2,575 to more than 2,800. And then the fall time change, the blue bar is taller than the red bar, so we see that after the time change we have fewer accidents. So it does illustrate the idea that accidents increase after sleep deprivation as a group and decrease after sleep indulgence. But let's look at this chart a little more closely. Look at the y-axis on the springtime change and look at the y-axis on the fall time change. They're trying to mislead us with this diagram because these are on vastly different scales, but they lined up the lines and everything to make them look like they're on the same scale. The change in the number of accidents is not as dramatic as it looks because we're zoomed in. And what you'll notice is that the springtime change jump, we go to an increase of more than 2,800. Look at the Monday before the fall time change. It's more than 4,000. So it's almost like we could argue that there's something about summertime more than sleep deprivation that's going on here. I'm not sure, but there's something wrong with this diagram. That's all I can say. I've alerted the publisher for years about this, and they're like, well, but we're just trying to illustrate the sleep problem. And it's like, yeah, this is why people think we lie with statistics, because we do this. So I'm pointing out, be careful in your interpretation of this. In fact, if we put them on the same scale, yeah, accidents go up in the spring and down in the fall, but nowhere near as dramatically as that previous slide had implied. This is all they had to do. I think it's still worthwhile to show that, yeah, when we started a higher rate in fall and then dropped to a lower rate. And by the end of winter, we'll be back down to where it was for the springtime change. Got to be careful about lying with statistics. All right, let's talk about a few sleep disorders. Insomnia is probably the one that, is the most problematic. There are different kinds of insomnia that you can have. The definition would be a persistent inability to fall asleep or stay asleep. So if this is chronic, this is something that's happening more nights than it doesn't happen, you probably are in the insomnia category. If it occasionally happens, that's called, that happens to everybody, right? So what we want to avoid is building up in our minds, I have a disorder, when it happens a few times, right? You can cause really bad effects when you start worrying about things. So, it happens sometimes to everybody. And what we want to worry about is when it's persistent. So there are biological reasons and things why insomnia might happen, but the most common explanation for people experiencing insomnia, which Homer obviously is not experiencing, is that they have things that they do around sleep that actually hinder the likelihood that they'll sleep. So I thought I'd go over a couple of sleep hygiene tips. Things that you could do to preserve your sleep. If you're a good sleeper right now, you want to be a good sleeper for the rest of your life. And you may notice that you're already doing some of these things. If you're having already hints that you might be sensitive and are maybe prone to insomnia, there are things that you can do to protect your sleep. So for one thing, something I probably most of us don't do is have a calm hour where you turn down the lights, you put away all the screens, TV, phone, tablet, everything's put away. I have a lot of students who say, well, I just turn my blue light down so my screen's not as distracting. Well, that's really not entirely the issue. It's the content. You don't want to be doing anything engaging leading up to sleep. You don't want to think to yourself, I can be completely absorbed in chatting with my friend, then turn it off. You don't want to be doing that. You want to have this calm hour. Now, I don't do a calm hour. I am a terrific sleeper. I have to just brag right now. I fall asleep about 15 minutes after my head hits the pillow. I generally sleep all the way through the night, and then I get up without I usually wake up right before my alarm goes off. So I'm a terrific sleeper. I have nothing but sleep hygiene. No, this is not because I'm a special person. It's because I follow sleep hygiene. I do not have screens at bedtime. But I don't do an hour. I turn everything off. I brush my teeth. I let the dogs in. I heat up my little bean bag that I like to put on my hands because my thumb has a problem. And, this all takes me maybe 15 minutes. And I do it in the same order every single night, like some kind of grandma. And if I miss a step, I'm like, how did I miss a step? It causes me a little bit of distress, right? Because my little calm hour is 15 minutes-ish long, and I just do the same thing every single night. You don't want to eat. You don't want to have caffeine or alcohol right before bed. A lot of times people think that alcohol will help them fall asleep, but research has shown that it actually delays the onset of sleep, so not a good idea. If you have difficulty sleeping, you really don't want to consume anything with caffeine in it after 2 p.m. because caffeine has an 8-hour half-life. So if you're going to go to bed at 10 or 11, 2 p.m. should be your cutoff with caffeinated beverages. My son-in-law drinks caffeine all day, and sometimes he goes, man, I couldn't get to sleep last night. It's like, dude, I'm drinking coffee at 9 o'clock at night. Really, you shouldn't eat food, but I have one caveat on that. If you have been running around and really busy all day and stuff, and you haven't had something to eat, your stomach's growling, you need to put something in it or you're not going to sleep well that night. So you want to do something that is easy to digest, isn't going to, be disruptive. And like the textbook talks about, the perfect combination is like whole wheat bread and some turkey and, a little mayo or something. Milk is good for that. It'll kind of fill your stomach and give it something to gnaw on so that you can sleep. You probably know certain things that work for you, but you just don't want to have like super spicy things right before bed that can kind of heat you up and stuff. You want to be very deliberate in what you might eat if you have to because you haven't eaten all day. This is probably the hardest thing for college students, people who have a job and classes and a family and all the things that we do. It's like, oh yeah, get up at the same time every day. You've got to be kidding me. I finally got to go to sleep. I am sleeping in. But if you have difficulty sleeping, if you're having insomnia symptoms, you want to make sure that every day, no matter how much or how little sleep you've gotten, you always get up at the same time. And if you are a person with insomnia, you do not get to take naps. You don't get to. You're trying to train yourself to sleep during the sleep times. And so while you're in that process, you don't get naps. If you're sleeping well, a nap can be a really good thing, and it needs to be brief, 20 minutes max. And insomniacs, a lot of times when they take naps, they don't do 20-minute naps. They'll sleep for 3 hours in the middle of the day. And no wonder you sleep 3 hours less at night, right? You have to give up naps while you're trying to retrain yourself to sleep in a big block at night. Regular exercise is terrific for sleep onset. You want to make sure that you're getting your heart rate up, that you are speeding up your metabolism, and then giving it time to cool down before you go to bed. So you do not want to exercise any closer than 2 hours before bed. You want to make sure that you've done it and completed it, and your body can cool down and get ready to go to sleep. This is another really hard one. If you're suffering from insomnia, you know what I'm talking about. You look over at the clock and you go, oh, if I fall asleep right now, I will get 6 hours of sleep. I'll be okay. I can do that. If I fall asleep right now, I'll get 5 hours of sleep, and I'll be okay. I can do 5. I've done 5, but right, and then you're doing math all night. It's better to turn the clock the other direction. In fact, you probably should do that anyway because the light from the clock is annoying. Don't look at it. Manage stress and anxiety. Oh, good luck, right? That's fun. How am I doing that? But being aware of it, working on it, doing breathing exercises, meditating, doing yoga, things like that can really help to eliminate those stress hormones and help you to be able to go to sleep. Now, on my list, I did say no screens before bed, but I need to update my list with one more sleep hygiene tip, which is do not sleep with your cell phone awake. Like it should not notify you of anything during the night. Put it into do not disturb mode. Take it out of the room if you can't stand it. I used to take my teenagers' phones away and make them leave them downstairs. And I discovered what a little weasel my daughter is because she'd go downstairs and get them. So I had to keep her phone in my room, which I didn't like doing, but because the little weasel would go down and get it. Being awakened by notifications or learning to sleep through them is not really good for your sleep. So just get rid of it, put it in do not disturb, or put it in another room, or turn it off or something. But we've all gotten really reliant on them, and we let our phones wake us up and do other things. And so it's really important that you put it in do not disturb so that you can get good sleep. All right. Couple of other disorders, and then I'll let you guys go. Narcolepsy, often referred to as sleep attacks. This is where the person collapses directly into REM sleep. They were awake. Usually something startles them or angers them or makes them laugh, and then suddenly they just collapse directly into REM sleep. Their body's completely paralyzed. Their eyes are rolling back and forth. Their genitals are aroused. Now, there's this video here. If you want to look it up on the internet, it's the worst. Girl with narcolepsy making her pass out. It's called her fiance sets it up so that she'll get startled, and then right after this image, she collapses into narcolepsy. Almost drops her lollipop from Disneyland. So if you want to watch that, it's kind of interesting in the sense that you get to see what narcolepsy looks like, and also, I don't mean to sound judgy, but what a mean fiance. So narcolepsy is that kind of sleep attack. Sometimes people think that they have that they have narcolepsy because they keep falling asleep every time they sit down, but that's more likely a symptom of sleep apnea, because narcolepsy, you collapse directly into REM. With sleep apnea, repeatedly throughout the night, your breathing stops and you keep having to wake yourself up to make yourself start breathing again. That's exhausting. People will go to bed, spend 8 hours in there, and wake up feeling like they've been through a prize fight because they've been struggling to breathe all night. So every time they sit down, they fall asleep. They don't fall directly into REM, they fall asleep. They just go into stage 1 and do normal sleeping things. So sleep apnea is the most common cause of daytime drowsiness. So this little Mayo Clinic diagram shows us how the fatty tissues in our throat, the muscles, as we age, they start to relax, and so then they'll block the upper airway, and that's called obstructive sleep apnea. Some people have a different kind that's biologically based that causes the reticular formation to stop communicating with the diaphragm while the person's asleep, and so they stop breathing because of that. If you have the obstructive kind, you might snore, right? If you have the reticular formation type, you probably don't snore, and you just stop breathing in your sleep. And sometimes people will go, all of us have times when we stop breathing at night. 30 to 60 seconds is not unusual. So we're talking about more like a minute and a half, 2 minutes without breathing. And then they'll like snort their way awake, and they have to move position or whatever so that they can start breathing again. And it's just exhausting for them. So, so sleep apnea might have snoring, might not. Not all snorers have sleep apnea. Not all people with sleep apnea have snoring, but snoring can be a symptom. Now, parasomnias I was alluding to earlier when I talked about sleepwalking. These are for my purpose, is going to include night terrors and sleepwalking. They're disorders surrounding sleep, so they're called para, because that means sort of around, somnia, which is sleep. So these always occur during stage 3, when you should not be dreaming. But for some reason, the person will get up and start walking around, or they may sit up and be terrified. They're like screaming. They'll get up and they'll run. They're just freaking out. Night terrors are not nightmares. A nightmare, you're paralyzed, you're experiencing this inside your head. A night terror, you're acting it out. And it's really realistic to the dreamer. This is a nice night terror video that illustrates like some sleep lab video and stuff like that. They always happen during stage 3. A person who's awakened from a parasomnia oftentimes will report that they were dreaming something. So some people think it might be sort of a malfunction of the REM stage, where you're actually experiencing some dreams during REM 3, non-REM 3. But it's hard to explain why some people experience it. It does seem to run in families. So if you were a sleepwalker, watch out. Your kids might be sleepwalkers. So it does seem to run in families. It's more common when we're younger. Like little kids are more prone to these kinds of events than older people are. When you have a little kid who experiences night terrors, you should not assume that something horrible must have happened to them in their waking day, and they're manifesting it in a dream. You should not think that at all. It's thought to be more of a developmental milestone. Like as kids are gaining language, they'll suddenly have night terrors, things like that. Very normal when they're little. Once we've made it through adolescence, most people stop having night terrors. They have fewer bouts of sleepwalking. Parasomnias usually wane. So if you have a person who's little, it's probably just developmental. If you have a person who's an adult, it might be a symptom of something. It might be an indicator that they've experienced trauma or something like that. In fact, night terrors are a symptom of post-traumatic stress disorder. So, it really depends on, is this something that, they've always done? Some people, they never stop sleepwalking. And so it's probably not a symptom of anything. It's probably this is how they're wired up. If they haven't been having night terrors, they've been an adult, everything had been fine, and then something acute happened to them and they suddenly are now having night terrors, those are probably a symptom of something. So it's not always bad that a person's having night terrors, especially if they're little. Okay. Enough on disorders. Let's go ahead and take a break here. We'll come back in our next segment. We'll talk about why we dream. Excellent question.